In this review, we're going to talk about parent functions and some transformations. First thing I'm going to do is find a parent function that I believe stands out from the other ones. In my opinion, I think the reciprocal is the easiest one to identify. Well, not maybe the easiest one, but it is very different from all the other ones. So I'm going to look for the reciprocal graphs. Remember, reciprocal looks like 1 over x. So I see that I have reciprocal in number 7 and number 12. So from here I want to find my vertex in each one of those. So remember, the vertex is opposite of inside, but on reciprocal the inside is in the denominator, so it's going to be the opposite of that 5, and then whatever's outside will be your y value of your vertex. So my vertex on number 7 is 5, negative 2. Then I can also look here or out here for a reflection or a stretch, but it doesn't look like I have one, so that will be all I'll have to recognize that one with. On number 12, the vertex is the opposite of my denominator for the x value, and the y value stays the same. This also has a 3 out front, so I know it's going to have a vertical stretch of 3. So I want to look in my graphs for the reciprocal functions. And if I look down here, I see that I have a reciprocal on this graph and this graph down here. So which one of these has a vertex of positive 5, 2? Positive 5, 2. This one could. This one's vertex is definitely at negative something. So I'm going to say that this one is going to be number 7 with a vertex of 5, negative 2. And this one's probably going to be number 12 with a vertex of negative 4, 4. And it does look a little more stretched than this one. So this is 12 and this is 7. I can cross those off now because I'm done with them. The next one, let's go with absolute value. That's another one that's fairly easy to recognize. So absolute value, I have an equation for absolute value in number 3, because remember, absolute value looks like an x with 2 bars around it. So I have an absolute value in number 3 and in number 6. So in number 3, the vertex is opposite, gives me the x value. Out there gives me the y value, and this also has a vertical stretch, this time of 4. Number 6, my vertex is going to be at negative 2, positive 2, and I'm going to have this time, since this number is smaller than 1, I'm going to have a vertical compression of 1/4. Remember, stretching means it will get skinnier, and compressions mean it will get wider in my absolute value. So I'm looking for my absolute value graphs. I see that I have one here and one here. This one is definitely wider, so I would say this one's going to have the compression, so that's going to be number 6, and this one's going to have the stretch of number 3. So let's just double check. Number 3 had a vertex of 2, negative 2. Could this one have a vertex of 2, negative 2? Yes, it could. And number 6 had a vertex of negative 2, positive 2. And I would say that's the vertex of this one. So I believe we're right on that. Let's move on. Next let's do a parabola, because it's easy to recognize. So I have a parabola down here on number 11, and I also have a parabola on number 10. So the vertex on number 10 is going to be the opposite of negative 4, comma 2, and then I have a vertical, is this a stretch or a compression? I hope you said compression, because that's correct, a vertical compression of 1/3. And then on number 11, my vertex is, what do you think it is? I hope you said negative 3, and we have a vertical stretch of 5. So this one will definitely be skinnier, and that one will be more wide. So when I look for my two parabolas, here and here, I see that this one is skinnier. So it should be the one that has a vertical stretch. Does it also have a matching vertex of negative 7, negative 3? Yep, so this one's going to be number 11. And this one has a vertex that looks like it's at 4, 2, and it is wider, so this one's going to be number 10. Now let's do square root function. Remember, that's the eyebrow. So I see I've got one here at number 2, and my other eyebrow is down here at number 9. So my vertex at the equation number 2 is going to be 4, 5. Does it have a reflection or a compression? No, it does not. So moving on to number 9, my vertex here is negative 2, 2, and it's got, what is that going to be? A vertical stretch of 3. So my eyebrow graphs are kind of far apart, so we're going to have to look at them one at a time. This one right here is my first eyebrow graph. It looks like its vertex, would this vertex be at 4, 5 or negative 2, 2? Well, definitely 4, 5, because it's not at negative anything. So we're going to say that's number 2, and we'll just double check that the other eyebrow has a vertex of negative 2, 2. Here's my other eyebrow, negative 2, 2. Yes, it does. Does it look like it has a stretch of 3? Yeah, because it goes up a lot faster than that other one did. So that one's going to be number 9. What am I left with? Oh, cubic and cube root. So cubic, remember, is x to the third, and it goes up like this. Cube root is cube root of x like that, and it went like this. So the squiggle and the sideways squiggle is what I'm still looking at. Let's do cubic first. So I see number 5 I have a cubic, and number 8 I have a cubic. So at number 5 my vertex is 7, 2, and I have a vertical what? Compression of 1/2. And on number 8 I've got a vertex of negative 1, negative 4, and I've got a vertical stretch of 2. Notice I just said 2. This negative does something else, something we haven't seen yet. Do you remember what it does? It gives it a reflection over the x-axis, which means it's going to face the other direction. So if I look for my cubics, I've got one here and I've got one here. Which one is facing the correct direction? That one's facing the correct direction, right? So let's see if this is number 5, because it did not have a reflection. Could this have a vertex of 7, 2? Yes, it could. And does it look compressed by 1/2? Yes, it does. This one is facing the wrong way, so it looks like it has a reflection. Does it also look like it could have a vertex of negative 1, negative 4, and a stretch of 2? Yep. So that one's number 8. My last two are my cube root, which is number 1 and number 4. On number 1 I have a vertex of negative 3, negative 4, and no other transformations besides those shifts. And on number 4 I have a vertex of 4, 2, and a vertical stretch of 5. So looking for my last two graphs, they are here and here. Which one looks like it's been stretched? This one definitely looks like it's been stretched. So let's see, could its vertex be at 4, 2? I believe it could. So this one's going to be number 4. So that just leaves us with number 1, but we always double check. Does this look like it has a vertex of negative 3, negative 4? Yep, so that's number 1, and we're done. Remember that for parent functions, a negative means a reflection. The number out front is a vertical stretch or a compression. Inside the parentheses is a shift, right or left, right being negative, left being positive, and whatever's after will be a shift, up or down, up being positive, down being negative.